What's up, guys? Hope you're doing well. I got something to show you. So you guys have heard of Sasquatch and the Yeti, but have you heard of the Like Monster?
Bobby M on the track.
Now we want to calculate the area on a coordinate plane, our XY axis. So we're going to start with the area for this one. So to calculate the area, well, if you identify what type of shape this is actually a trapezoid. The formula to calculate the area of a trapezoid, area is equal to 1/2 b1 plus b2 times the height. So to calculate the area, that's what we're going to do. What's b1 and b2? The b1 and b2 are the bases. Here's a base, here's a base. This is actually my height right there. So we have both bases, we have the height. To calculate the length of those, it's fairly easy to do because you just count 1, 2, 3, 4, 5, 6, 7. So 1/2 7 plus 1, 2, 3, 4, 5. The height 1, 2, 3, 4. So you get 1/2. Make sure you use PEMDAS. 12 times 4, I would do 12 divided by 2 is 6. 6 times 4 is 24. And we're just going to say unit squared, UN squared. That's the area. That's how I calculate the area. Now let's look at the, let's go ahead and look at the perimeter in just a second. Let me delete this, cover this back up. Now let's calculate the perimeter. Remember, the perimeter is just the distance all the way around the shape. So this is fairly easy to do because all you have to do is just count. So I can count each side. The perimeter is equal to BC plus CD plus DA plus AB. Most of these are horizontal or vertical lines, so I can count those units. BC was 5. That was 5. AD was 7. Or DA was 7. BA was 4. Let's see, 1, 2, 3, 4. Yep. But the only one I have, oops, wrong place. The only one I have issues with is CD. I can't just count that one because it's at an angle. It's a diagonal. Well, diagonal line. It's not the diagonal, it's just a diagonal line. So how do I calculate the length of that side right there? Two ways I could do it. I could use a distance formula and take this coordinate and this coordinate. So those two coordinates, use the distance formula to calculate the length between both of those, or the distance between both of those points. That would give me the length of that segment. Perfectly fine if you do it that way. But I'm going to use the Pythagorean theorem because I have a right triangle here. Base here is 2. The height is 4. Don't know what the hypotenuse is. So, undo that. Time out. Sorry about that. Okay. So to calculate the hypotenuse here, use the Pythagorean theorem. 4 squared plus 2 squared is equal to hypotenuse c squared, or x squared. Put a c right here. Actually, I'm going to put an x because I already used c. X squared, which then gives me 16 plus 4 equals x squared. X is equal to, x squared is equal to 220. Square root both sides, root 20. That's the same thing as 4 times 5. The square root of 4 is 2, so I get 2 root 5. So CD is 2 root 5, which when I add all of these together, I could convert the 2 root 5 to a decimal number. Be easier to work with. That's 4.5. So when I add all these up, I get 20.5 units as the perimeter, the distance around the shape. That's how I calculate the perimeter. Use the distance formula or Pythagorean theorem after you create that right triangle. All right. 2 more slides. Estimate the area of this irregular shape. Now this one, the easy way to do this, I would just suggest counting. So here, we're going to be looking at this shape here. Let's just go ahead and start counting. Estimated full squares. So that would be 1. So I have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're at 20 right now. Now I'm not going to count this one right here because it's not a full square. So I'll come back to that. So we're at 20. I'm not going to count this one. 21, 22, 23. I'm not going to count this one. So I have this one, and this one to come back to. Lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we're at 27 right now, and I haven't counted those highlighted squares. But notice that these highlighted squares here, they're triangles. They fill up half of the box. So all I'm going to do is add them both together to get a full square. So 27, 28, 29, and we get approximately 30 units squared. Now this is an estimate, right? It's not 100% accurate. We're just saying this is what approximately the area is. So I'll give you guys probably plus or minus 1 square unit when you guys do this on the test. It has to be relatively close. If it's not super close, if you're way off, you won't get credit. But if you're within plus minus 1 units, I'll give you credit. But that's all you got to do. Just count the individual boxes. The shapes that don't add up to a full square, just combine them with the other shapes in order to get a full square. All right, last one. So this one's pretty interesting because I have this shape that I want to calculate the area of. I'm going to calculate that area, but it's really hard to do if I just try and figure out a way to calculate it just directly. So this is actually going to be an indirect area calculation. So what I mean by this is that I'm first going to calculate, just a second, the area of this big rectangle that completely encloses that polygon here. So that big rectangle has a base of 1, 2, 3, 4, 5, 6, 7. Did I miscount that? Just a second. Let me double check that. 1, 2, 3, 4, 5, 6. My bad. So the base is 6 units. The height is 1, 2, 3, 4, 5, 6, 7, 8. So the area of this big rectangle here is 48 units squared. But that gives me all of this area. What I want is just this portion here. So since I've calculated all of this rectangle, what we're actually going to do now is calculate these triangles here. So I have these 3 triangles here. I'm just going to subtract them away. I'm basically going to cut them off, and I'll be left with this area of the polygon. So calculate the whole area, get rid of these rectangles here, you'll be left with the area that you want. So it's going to calculate those individual, let me keep that actually, triangles here. Let me make this a little bit better. So there's a triangle, there's a triangle, there's a triangle. So let's call this one A, B, and C. So to calculate the area of that triangle, we have 1/2 base times height. Well, the base here is 3 units, so you just count 3. The height is 6. So 1/2, 6 times 3, that gives you 18 divided by 2, 9 units squared. Now let's calculate B. Let's see if I can do this. We have 1 unit here, and then this is 1, 2, 3, 4, 5. So we have 1/2, the base was 1, 1 times 5. So that's 5 over 2, gives you 2.5 units squared. Now we're just left with, erase this to make it a little bit easier to see, left with C. Well, the base of C (1, 2, 3, 4, 5). The height is 1, 2, 3. So 1/2, 5 times 3. That gives you 15 over 2, 7.5 units squared. So to solve for the total area, we'll take the area of the rectangle, which is this right here, 48. We're going to subtract the total added area of the 3 rectangles, those 3 numbers right there. So 9 plus 2.5, plus 7.5. So I'm going to take away all these triangles and be left with only the area of the initial polygon. So I get 48 minus 19, all these add up to 19, which gives me the total area of 29 units squared. And there you have it. Alright guys, if you have any questions, make sure you email me. We'll try and figure out the best way to address questions at a later, or just email me. We'll come up with something. Hope you guys liked it. Have a good day. Bye.